Okay, good afternoon, ladies and gentlemen. Let's get rolling on the blue proof. So this is the one that was on the blue piece of paper in class today. Again, it's available for download on Emoto, my Emoto site, which most of you guys are actually part of now, which is awesome. So let's get into it. Now, again, the most important part of any kind of proofing is that you understand what you're about to do before you actually start writing the proof. Again, as an admonishment, like I saw several people who just started writing a proof and they're like on 5 step or 6, but they couldn't explain where they were going with it. That's not a bad thing to do. Like, let me explain what I mean. Like, a very natural thinking math process is kind of working and thinking at the same time. But in terms of proof and writing it very efficiently, you might be doing a lot of stuff extra if you're not being careful. So let's see if this makes sense to us. So the first thing I'm going to do, just like I've done several times now, I'm going to rename some angles. So I'm going to call that angle 1, the angle 2, and call that angle 3, and that angle 4. Right? Which means that you probably need to change these too. So really, ABC is now angle 1. EDC is now angle 4, and I have to prove that angle 2 is congruent to angle 3. Let's see if this makes sense to us. Let's see if this even should be possible. Well, some things else I'm told is I have a couple perpendicular angles, meaning these guys right here are right angles. I mean, that's what it means to be perpendicular. And that was misunderstanding, I think, that we carried in class today. If angles are perpendicular, the only thing you know about them is that they're right. Again, structure goes to relationship. So perpendicular structure goes to relationship of right. The right angle, the relationship, gives you a number, in this case 90. So angle 1 and angle 2 together make 90, 3 and 4 together make 90. So what, just suppose, and we can't use this for proof, but let's just pretend this is like 30 degrees. Well, that means this would have to be 30 also. But if these are 30 and these are both 90, that means these have to be 60. So in other words, these have to be the same simply because we're taking the same amount away from 90 degrees. Like if they start at 90, I take away 2 congruent angles, one here and one here, no matter what the measurement, whatever's left must be the same. This is like saying, hey, I'm going to give these 2 guys right here both $90. Then I'm going to reach in and steal the same amount from both those guys. Well, logically, of course, they're going to have to be left with the same amount. That's how this proof is written. That's why these things have to be the same, angle 2 and angle 3. Okay? If I start at 90s, which is really kind of my first step, show that I'm subtracting the same amount from both sides, whatever's left has to be congruent too. And that's the 3 big steps of my proof. Show that these are 90s, subtract off the same angle from our givens, and then reason that the 2 angles left, the measurements, or excuse me, not just reason, but show the 2 remaining measurements have to be the same as well. Ooh, excuse me. So that's how we're going to write this proof. I bet you guys just yawned too, because I just yawned. That's how it works, it's contagious. All right. So again, the style that most people are latching onto, the one that people are saying has helped them the most, has been 2-column. So I will, of course, honor that and be writing this one in 2-column form as well, even though I kind of find it just a little bit boring. I will humor you guys. Okay. So again, here we have our statements. And our justifications. Okay, so let's get to it. Now, again, it looks like I erased this, but I'm going to renumber this, and that's just really going to be for ease. That's always a perfectly legal thing to do in proofs, is to relabel the way things are named. I think it's a little bit easier than using 3 letters at a time, but that's just personally me. If you want to keep the 3 letters, by all means do it, but I'm going to be using these 4 numbers for my angles. So let's go ahead and write in our givens. So here we have a given statement that AB perpendicular to BD and ED is perpendicular to BD. Now, a lot of you guys caught on that each of these givens actually helps us with one of our stages in our proof. So what I'm going to do is something I haven't really done before, which is not write my other given statement in quite yet. I'm going to write it in eventually, but it's only when I'm going to need it am I going to write it. So I'm going to go ahead and squeeze all I can out of this particular statement that I've just written, that these angles are perpendicular. Okay. So knowing that they're perpendicular, the next thing I naturally know is the relationship. If these are the perpendicular structure, the relationships of the angles are what I need to state next. So angle ABC and angle EDB are right angles. And that's going to be because of the definition of perpendicularity. If I know they're right, I probably know something just a little bit more. And that's, I know that angle ABC is going to equal 90 degrees. And I should probably throw a measurement right here, which is also going to be equal to the measurement of angle EBD. What I've written here is a compound equation. I don't know if you guys are familiar with these from algebra last year, but if I know they're both equal to 90, I can write them as actually one equation with two equal signs. That's okay to do. Not in all cases. You got to kind of be careful with that, but in this case it is because they're both equal to that middle number of 90. Okay, how do I know this? This is going to be by the definition of right angles. Okay. Now, what I actually need is like these 1s and 2s, not these ABCs and EBDs. So I'm going to have to take a step here and actually try to convert these to 1s and 2s and 3s and 4s. Well, what do I know? By the angle addition postulate, I know that the measurement of angle 1 plus the measurement of angle 2 equals the measurement of ABD, or ABC, excuse me. Okay, I also know that the measurement of angle 4 plus the measurement of angle 3 equals the measurement of angle EBD. And I know those because of the angle addition postulate, AAP. In other words, if I add angles together, if I add the small parts of the angles together, I get the entire angle. So if I add measurement of angle 1 to the measurement of angle 2, I get the measurement of angle ABD. Likewise, if I add the measurement of angle 4 to the measurement of angle 3, I get the entire measurement EDB. Okay? So now, take a look at this. I know that measurement of angle 1 plus measurement of angle 2 is equal to ABC, which is equal to 90, which is also equal to angle EBD, which is equal to angle EBD here, which is also equal to angle 4 plus angle 3. I think I just made a transitive chain. Angle 1 plus angle 2 is equal to ABC. ABC is equal to 90. 90 is the same as EBD. EBD is the same as angle 4 plus angle 3. So using transition, the measurement of angle 1 plus the measurement of angle 2 is equal to the measurement of angle 4 plus the measurement of angle 3. This is really, really good news. Okay. Why is that good news? Well, look at my givens. I have to show that 2 and 3 are congruent. If I know they're congruent, to show they're congruent, I have to show the measurements are equal. I'm almost there. I have measurement of angle 2 equal to the measurement of angle 3. I just have to get rid of 4 and 1. So if I can somehow show that 4 and 1 are the same measure and then subtract them, I'm in business. Oh, wait, wasn't that a given? Yeah, that was a given. That was my sarcastic voice. So that's where we're going next. So step 6, we have to establish 1 and 4 of the same measurement. Well, where do I start? Well, I start with a given over here that I haven't used yet. So angle 1 is congruent to angle 4 will be my given. Okay. And if they are congruent, I know their measurements have to be the same. And that's just by the definition of what it means to be congruent. Okay. Well, again, I wanted to show that 2 and 3 were congruent, which means I have to show 2 and 3 are the same measure. I just have to get rid of 1 and 4, but they're the same value. I just showed it down here. So I'm going to modify my equation so it looks the same. And again, that's something I know that we've been struggling with. But if I want to change an equation, I need to make sure it looks right first. I know, especially from algebra, you guys are so used to skipping so many steps. And I know we're not disputing the algebra, but again, we're writing this proof for someone who doesn't really know all those intermediary steps, who can't think as fast as you guys can think. So it has to look the same to them. Okay, so after substituting in my values, now I can subtract. Oh, wow. I was talking while I was doing that, and now I need to go back. Okay. So I apologize if you were following along because I really messed that up. Okay, I want to exchange angle 1 for angle 4, so I'll keep the first one. Okay, and again, I do apologize for messing up. I was going too fast and I think when I was writing, but I'm replacing the measurement of angle 4 with measurement of angle 1, and that goes back to this idea that someone reading this proof has to look the same to them. So even though we know intuitively that 1 and 4 are the same, so if I subtract from both sides, they cancel themselves out. I have to show that in my equation first algebraically. It has to look that way. And then I can claim angle 2 has the same measurement as a measurement of angle 3 by subtraction. Okay, and of course, if they have the same measurement, then angle 2 has to be congruent to angle 3 by the definition of what it means to be congruent. Okay. So purple step is establishing that these angles 1 and 2 together and 3 and 4 together are the same measurement, ending in step 5. Red step was showing that 1 and 4 have the same measurement, and then black step, is subtracting off the equal 1 and 4 pieces, and then leaving just the equal parts 2 and 3, and the measurements are the same. Of course, they're congruent. Okay. So again, a really good one to study for tomorrow. If you have questions, post them at Edmodo. I'm going to be kind of looking at Edmodo pretty much consistently all night tonight. And by all night, I mean until I try to go to bed, probably around 10 o'clock. But if you have questions about any of these proofs, by all means, post the questions. Also, you guys have the ability to post videos, so if it's a question that you have a hard time typing out, maybe shoot a video of yourself asking the question and post that, and I'll try to respond. It might be the only way that you can communicate with me really well over this kind of board. Okay, so good luck to you guys. Study hard. I'll see you guys tomorrow.